Good morning all of you. I am Tanushree Dai from Civil Engineering branch, and today I am going to teach you your Theory 2 paper, which is Structural Design 2. So in the last class we solved a numerical on bolted connection, and today we will discuss another numerical on the bolted connection, which is based on three kinds of connection. One is lap joint, single cover butt joint, and double cover butt joint. So here is your question, which is two steel plates of grade Fe410 of 16 mm thick are to be joined by 24 mm dia bolts of grade 4.6, assuming a pitch of 60 mm and edge of 40 mm. Calculate the strength of the bolt of the following case. So your first case is lap joint, second case is single cover butt joint, on which the cover plate is given as 12 mm thick, and last one is your double cover butt joint, in which the cover plate is used 10 mm thick. Double cover means two cover plates are there. One is your on the side and another is your below the plate. So both the cover plates are of 10 mm thickness. So let's solve it. So what are the data givens? So the data givens are thickness of the plate is given as 16 mm, which is your main plate. Then pitch distance is given as 60 mm and edge distance is given as 40 mm. And the grade of the steel is given as Fe410 grade steel, from which we can identify the Fu, which is 410 megapascal or Newton per mm square, and Fy, which is 250 megapascal or Newton per mm square, which is you can find out from the table number 1 in IS 800-2007 code. Okay, and the bolt of the diameter of the bolt is given as D equal to 24 mm, and your FUB for grade 4.6 for the bolt is given as 400 megapascal. So to solve this problem, the partial safety factor we need, which is gamma MB, which equal to 1.25, which is already given in the table number 5 IS 800-2007 code. So now we have to solve the first case, which is lap joint. So you can see the diagram of the section, that is two main plate are there, which is connected by lap joint, and the lap joint is provided with one single bolted connection. The main plate thickness is given as 16 mm. So here we have to draw the 16 mm thick of the each main plate. Okay. So now come to the strength of the bolt. You know that the strength of the bolt is divided into two types. One is shearing strength and second one is bearing strength. So in the shearing strength, we need a formula, which is nominal shearing strength, which is VNSB equal to FUB divided by root 3 NNANB plus NSASB. So here you can see the clause number 10.3.3, which is the clause number in the code book. You can see in this code book you can find out this formula. Okay, you can directly find out the formula from the code and put it here. So here NN and NS is the number of shear plane at thread and number of shear plane at sink. So in case of lap joint, your number of shear plane in thread section is 1 and number of shear plane at same portion is 0. Okay, and your A and B you can calculate it by 0.78 pi by 4 d square, and ASB you can calculate by the formula pi by 4 d square. Okay, so while you put this formula here, you can get the answer as 81522 Newton. After that, you can convert this Newton answer as kilonewton, which is 81.52 kilonewton. Then we have to calculate the design strength in shear. That is the ratio of nominal shear strength and partial safety factor. So nominal shearing strength is 81.52, which we got from this formula, and your gamma MB is 1.25 from table number 5 in code 800-2007. Then we will get the value 65.22 kilonewton. Okay. So now come to the bearing strength of the bolt. So we know that the nominal bearing strength of the bolt is given as V NPB equal to 2.5 kb dt fu. So here the size of the bolt is 24 mm. So for the D value 24 mm, the D0 value, that is diameter of the bolt hole, is given as 26 mm. So for the calculation of the KB, we need 4 criteria. So first criteria is E by 3D0. Second criteria is P by 3D0 minus 0.25. And third one is 0. FUB by FU. And fourth one is 1.0. So in the first criteria, you put E as 40, which is given in the question, and D0 we can find out from here, which is 26, which equal to 0.513. And like this, you have to put the value of pitch and D0 over here, which is 60 and D0 is 26. So 60 by 3 into 26 minus 0.25 equal to 0.519. And third one is your FUB by FU. So FUB value is 400 and FU is 410, which equal to 0.975. And last one is your 1.0. So the least value among these 4 is your 0.513. So your KB value is 0.513. So we directly put the KB value as 0.513 in this formula. Okay. So the formula is like 2.5 multiplied with KB, which is 0.513 into D, which is 24 mm, then T, which is your thickness of the plate. So here the two plates are of same thickness, so we take the thickness of the plate is 16. If the plate thickness is different, then you will take the thinner plate thickness. Okay. Next one is your FU value, which is 410. So by calculating the whole formula, we will get the value 201917 Newton, which is 201.917 kilonewton. Okay. So this is the value of nominal bearing strength. So to calculate the design bearing strength, we need to divide the partial safety factor with nominal bearing strength. So we directly put V NPB divided by gamma MB. So your V NPB equal to 201.917 and gamma MB equal to 1.25, which equal to 161.2. 533 kilonewton. So the design strength of the bolt is the minimum of shearing strength and bearing strength. So you can see the design shearing strength we got 65.22 and design bearing strength we got 161.533 kilonewton. So the minimum is the shearing strength, which is 65.22 kilonewton. So here the strength of the bolt, which is VDB, is minimum of strength in shearing and bearing, that is 65.22 kilonewton. Okay. So this is the solution of case 1. So now comes to case 2, which is single cover board joint. So in case of single cover board joint, you can see the figure. The two main plate are coincidentally jointed here. Okay. And over it another cover plate is there. You can provide the single cover plate either in the upper side or in the lower side also. Okay. So here we provide the cover plate on the upper side. So in the question, the thickness of the cover plate is given as 12 mm and the thickness of the main plate is given as 16 mm. Okay. So in this case, the calculation of the design shearing strength or design shearing strength of the bolt is similar with the lap joint. Okay. So that here we don't need to calculate again. So we directly put the value of design shearing strength as 65.22 kilonewton. If the plates are different, then we need to calculate it again. But because we already calculate that portion in the lap joint here, so we don't need to calculate again. Okay. Then we directly calculate the design bearing strength here, because in the bearing strength the value of thickness is different from the lap joint, because in case of lap joint we took the value of thickness as 16 mm because the main plate thickness are 16 mm. But here we need to calculate the thickness as thinner thickness of the plate from main plate and cover plate. So the cover plate is 12 mm and main plate is 16 mm. So the thinner thickness of the plate is 12 mm, which is the thickness of cover plate. So here the thickness is changed. And the calculation of KB also similar with the lap joint. So you can directly put the value of KB value from this criteria. So here also we don't need to calculate the KB value again. So you can directly put this value in that formula. Okay. So next one is, you can see here the strength of the bolt, that is your bearing strength. You can calculate directly here 2.5 kb dt Fu divided by gamma mb. So gamma mb value is 1.25 and kb value is 0.513 and d is your diameter of the bolt, which is 24 mm, and d is your thickness of the thinner plate, which is we took 12 mm, which is the thickness of the cover plate, and Fu value is 410. So by calculating the whole formula, we will get 121150 Newton, which equal to 121.15 kilonewton. Okay. So the design strength of the bolt is minimum of the design strength in shearing and design strength in bearing, which is 65.22 kilonewton. So today this much. We will discuss the last case, which is double cover board joint, in the next class. Thank you.